Welcome to another video on nodal analysis. So in this video we'll be trying to find the node voltages of the circuit, and as you can see we have been given our reference node and our nodes have been numbered for us. So all we just have to do is to proceed to write the KCL equation the way it is written in nodal analysis. So at node 1, so we have the current flowing out of node 1 through this branch. That will be V1 minus V3 divided by 4. V1 minus V3 divided by 4. Then we have the current flowing out of node 1 through this branch. That will be V1 minus V2 divided by 2. So plus V1 minus V2 divided by 2. Then we also have the current flowing out of node 1 through this branch, and that will be minus 3, because the current is not flowing out, it's actually flowing in, so it will take a negative sign, 0. So multiply through by 4, and then we get V1 minus V3 plus 2V1 minus 2V2 equals 12. Then we'll just do our additions, and we have 3V1 minus 2V2 minus V3 equals 12, and we can call that our first equation. Then we come to node 2. Then at node 2, this resistance should be 4 ohms. So at node 2, say the current flowing in this branch would be V2 minus V1 divided by 2. V2 minus V1 divided by 2. Then the current flowing here, recall that this is a reference node, so it is 0. So then that will be plus V2 minus 0 divided by 4. Then we have V2 minus V3 divided by 8 plus V2 minus V3 divided by 8. So that will be equals to 0. So we can multiply by 8. We can multiply through by 8, and then we would have 4V2 minus 4V1 plus 2V2 plus V2 minus V3 equals 0. Simplify that further to be minus 4V1 plus 7V2 minus V3 equals 0, and this will be our second equation. We can proceed to node 3. Then at node 3, we write for this branch, that would be at node 3. So that this branch should be V3 minus V2 divided by 8. V3 minus V2 divided by 8. Then this branch should be V3 minus V1 divided by 4 plus V3 minus V1 divided by 4, then plus 2ix, because the current is flowing out, so that will be plus 2ix, which is equals to 0. Now this is the equation at node 3. Now you see that ix is the current flowing in this branch, so ix would then be V1 minus V2 divided by 2. So we can come down and write that ix equals V1 minus V2 divided by 2. Then we can substitute that in this equation. Then we would have V3 minus V2 divided by 8 plus V3 minus V1 1 divided by 4 plus 2 into bracket V1 minus V2 divided by 2 equals 0. So we can then proceed to multiply through by 8. So that would be V3 minus V2 plus 2V3 minus 2V1 plus 8V1 minus V2 equals 0. It's supposed to be 8V2, sorry. We can then proceed to say that 6V1 minus 9V2 plus 3V3 equals 0. Divide through by 3, then we would have 2V1 minus 3V2 plus 3V3 equals 0. We can then solve this simultaneously with the help of our calculator, since this is our third equation. And V1 would be equals to 4.8 volts. V2 would be equals to 2.4 volts, and our V3 would then be equals to minus 2.4 volts. Watching the video, please support the channel by liking and subscribing to the channel. See you in the next video. Bye.